So this one is the one I haven't taught you before. You've never seen that formula before. And what does it do? Well, it takes a geometric series. Remember, that's the kind where it's like 2 times 3 is 6, times 3 is 18, you know, the times kind. It takes those and it adds them all up. All right, so you haven't seen that one before. This one may look different than what you're used to. This is the kind where it's arithmetic, where it's like 2 plus 3 is 5, plus 3 is 8, dot, dot, dot. And this is the one that little Friedrich used, but it's definitely different because what they did is they canceled off some stuff. I taught it to you this way, n over 2 times 2a plus n minus 1 times d. Now, do you see that right here they have the a sub n formula as just a sub n? So in my opinion, this one is much better because this one makes you recall a different formula to stick into that formula. So I would write this one next to it because I think this is better. I know this one's shorter, and it's great as long as you know what the a sub n formula is, which is right over here. You have to put all of that inside this formula, and then you'll get this one the way I taught it to you. Okay, and this was the any term when it comes to a geometric. This is the any term when it comes to arithmetic. All right, with that little review of those formulas, I'm going to give you 4 questions. Nope, 5, I'm wrong. And I'd like you to see where you are at this point. Do you know how to do these 5 things? And again, I understand there might be 1 or 2 of them that you might not do well on, but then hopefully you'll learn from that and go, oh, I guess I didn't know how to do that. All right, so here we go. If you're in the classroom with me right now, you're going to see them written on the board, but I'll write them for those at home. For this one, the series starts 1, 3, 5, 7, and you guys all know this is the odd numbers. But I'm going to only go out 10 terms. And so what, Mr. Server, what do you want? I want you to write that as the sum of, that's the little sigma. I want you to write a sigma for me. You know, a number goes here, and a number goes here, and some kind of variable thing goes there. If you've forgotten how to do that, I'll remind you. But that's your job on number 1. Write a sigma for that set of 10 terms so that it would add them all up. And the question is, for this one, what is the answer to that? I'll tell you, it's not 140. But there's some numerical answer to that. To the first 10 terms of the odd numbers. Number 3. If you have a geometric, I guess I have to change this question, so don't do the one on the board because it already gives you the answers. I'm going to give you a different one. And we had (1/6) here and 1/36 here. You'd be able to figure out what were the first and second terms. I am going to say that underneath this line, these are all geometrics. You have to know that, otherwise you could have 2 different answers based on whether it's arithmetic or geometric. But below that red line, these are geometric questions. Number 4, if I have 4, and then 12, and then 36, and it keeps going, what's the 6th term? And I am okay with you leaving an answer of it's 4 to the 3rd power minus 2 or something. It's okay to have an answer in that form because the power is kind of daunting to actually figure out in your head. Last, what is the sum of these 6 terms? And to do that, you will need this new formula that you were just given right here. You might believe you never even showed us how to use it. Don't really need to. If you know what A is, and you know what N is, and you know what R is, you stick them all in, you'll be able to figure it out. All right, so act like the test is today. When is the actual test on this stuff? Well, it's not even tomorrow. We have a review day tomorrow. And then Thursday of this week, we have this little test. And this test is going to be smaller than normal. I think we're going to make it worth 20 points. And the normal test is worth 100 points. Okay, so 1/5 the size of a normal test. But still in the summative, so take it seriously. It's Thursday. That way you can't just crash your grade with one bad test. And you will still have the option to retake it, because it's a summative. Not that we have to always give you retakes, but there's enough time left we can process a retake between now and the end of the year. Yes?
Is the second one find the sum of the first question? Or what's
Yes, yes. You're right that I think I said it verbally, but I didn't write it. So I want you to find the sum of those first 10 terms, like it's a number. This one, you're writing a problem for me. On problem 2, you're actually telling the answer to it, which is a number, it's just not 140. All right, so I'll give you a little more time to work. And then I'd like you to first work independently, and then I'll have you work with somebody else in a minute to kind of fill in any weak spots that you have. Okay, so here's how to do that 1, 3, 5, 7 thing. So first of all, if they want the first 10 terms, I've told you to always is a big thing, always start with a 1 here if you have a choice. And you did have a choice, so I would have started with a 1 there. And if you want 10 terms, you can, that's part of why I say always start with 1. If you started with 0, you wouldn't go to 10. So always start with 1, and then you can just go to, if you want to go to 10, you go to the 10th term, and they got a 10 there. Then, this is the any term. And the any term is a sub n equals a plus n minus 1 times d. Now, if you just wrote that, you would be really close to having the answer. Right after the sigma, you want this. But then you actually have to put in a and d. So what is there a? A is the first term. So the first term in this sequence, which was 1, 3, 5, 7, would be a 1 right there. And then the d is the common difference, and we were just adding 2 each time, right? No, wait, I'm going to double check that. 1 plus 2 is 3. Yes, we're adding 2 each time. Okay, so then could you simplify it even further and just multiply this out? 1 plus 2n minus 2? Yes, you could. And then this would be simplified down to sigma 1 to 10 of 2n minus 1. Who got it all the way down to that? Good. Did anybody leave it with the 2 and the 1 in there, but you left it like this? I respect that, and it's okay. You can do that. It's allowed. Okay. How many of you, be honest, would have had that one marked wrong because you did not know for sure how to do that? All right. Several honest people. I appreciate that. Do you get how to do it now, though? That's the key thing. You just take the any term and stick in the a and the d. All right. Now, number 2 was to get the sum there. Well, there is a formula for that. So if I'm going to take 1, 3, 5, 7, and I'm going to find the sum of that, I'm going to do the little Friedrich method. He took the first number and the last number, which is the any term. But it is true that there's an a plus an a right there, so a lot of times in your formulas you see that written as 2a. Okay, and then I'm going to stick in my numbers. My n is 10 terms, so I put in a 10 there. And then 2 times the a is 1, so I put a 1 there. And the d was, it's going up by 2 each time, so the d is 2. All right, so then this is 2 times 1 is 2 plus n minus 1. Well, I want 10 terms, so I should put a 10 there. 10 minus 1 is 9, times 2 is 18. And that's all times 5 or 10 over 2, which is 5. So that's 20 times 5, which is 100. Raise your hand if you had 100. Okay. So, Noah, did you have 100? Okay, good. All right. So on to, how many of you got that one right? I need to see that one more time. So if I should see if I should probably, oh, good. Most people had that one. Okay. So So this one, how could you figure out what they're multiplying by? Well, you could kind of just think, but do you get, instead of just, oh, I realized it was times 1/6, do you get you could have divided this divided by this? So if I give you a more obscure one like 2.3, and then the next term is 17.9, would you be able to figure out, well, what I added would be super easy, right? But what did I multiply by? Well, I multiplied by 17.9 over 2.3. If I put that in here, it might make it more obvious. If I put 17.9 here, divided by 2.3 here, do you get all the 2.3s would cancel and you'd get 17.9? All right, so that's the common ratio right there. If you divide this one divided by that one. So I know this one was pretty obvious, but it would have been that divided by that. So then I realize my common ratio, well, I can just kind of put it in reverse. Instead of multiplying by 1/6, I can flip it and times by that. So I'm really timesing by 6. So if I times this by 6 and I go backwards, I get 1/6 times 6, which is 1. And then I times by 6 again, and this would have had to have been a 6. Who had 6 and 1 in those two spots? Okay, good. We're doing pretty good there. On to this one, I want the 6th term. Well, there's a formula for that. Hopefully you knew it. It was off the list up above, but it starts with a times r to the n minus 1. All right, so what is a? A is 4. Times r, which is the common ratio, which is 3. Because I take this divided by that, it will tell me 3. And then to the n minus 1, well, which one do I want? I want the 6th term, so I put a 6 there. 6 minus 1 is 5. And I said you could leave it like this. How many of you had 4 times 3 to the 5th? Or actually figured out the final answer? Okay, good. And last but not least, the sum of those 6 terms. That's the new formula. Remember, it starts with 4, and I'm timesing by 3. That's all I really need to carry with me here is it starts with 4. And its common ratio was a 3. And n is how many terms they want me to do. How many terms were there? 6 terms. So n is 6. All right, and I would be okay with you simplifying this down a little bit. Do you get this 4? And this divided by negative 2 could be simplified. Now, if you left it, I understand, and that's okay. If you left it like this. Now, you should have at least done 1 minus 3, which would be negative 2. But do you also get I can do 4 divided by 2 and get a 2? And I just got to make sure I don't lose the negative. So then it would really be negative 2 times 1 minus 3 to the 6th. And again, on a test, if there was that big of a power, I'd let you leave it that way. But 3 to the 6th is doable. It's just kind of a big number. Did anybody actually get the final answer? Things like 1,400 or something like that? Yes?
1,456.
1456. Anybody else verify that?
Yeah.
A bunch of kids did. Good. I'm curious, of the kids who did that, how many of you did it in your head? Like no calculator used?
No calculator, but I wrote it.
Okay. All right. A couple kids. All right. All right. So what haven't I covered here that I have covered in the past? As in, what else could be on your test, but we haven't talked about it? That would be something like this. You don't know the first term. Everybody write this one down. You don't know the first term. You don't know the second term. But you know the third term. And the third term's going to be a 4. And you don't know the fourth term, but you know the fifth term is going to be a 100. Now, from what I've told you so far, there's one key thing missing that I haven't told you that I'd have to tell you in order for you to get this problem. Arithmetic or geometric. Do you get I could be multiplying by something or I could be adding something? Okay, good. Now, and you can't tell from what I've told you. So I'm going to do the harder of the two, and that's where it's multiplying by something. So figure out, if I'm multiplying by something, then what am I multiplying by? Wait. And therefore, what's your R, which is the common ratio, and what's your A? And I'm not going to ask you anything more about like what's the 73rd term or whatever. I could theoretically, but I think this problem is dense enough. So now my hint to you is, I know some of you could do this in your head, and you could like go through numbers and go, well, what could he have multiplied by that would work nice? The one on the test, you will not be able to do that. So if you just guessed and checked to find this one, then you need to watch how you can solve this with two equations. You need an equation for this, but wait, you won't know the R and the A. You're right, you won't. So the answer will have an R and an A in it. That's your equation. It has an equation that has R and A in it, and then you'll have another equation, because this is a key theme about this class. If you have one, you've always known if you have one variable you could solve. But what if you have two variables in the equation? Then you just need two equations to solve it. That's what we've got here. And by the way, if you ever have three variables, which happens near the end of this school year, spoiler alert, you need three equations. Very good. Okay, it's not that complicated. If you have one equation with one variable, you can solve it. But if you have two variables, you need two equations. So can you write me two equations for this? Well, I'm going to remind you, you have, if this is geometric, I'm going to write that officially, this is geo, then that brings you down to just two possible equations you could use. And I never talked about the sum of anything here. So that's one of the equations, and we don't need that one. So then what's the other equation? Drew, there's only one other equation. You can look on the notes if you want to. What's the one equation that you must have to use?
A times R to the n-1.
Make sure you have both sides of that. I'm going to say a sub n equals a times r to the n minus 1. Very good. And now it always comes down to these equations. Which, yes, in the real world, you can look these up. You know, like if you had a job that was about this, I know, you might be like, I'm never having a job like that. You don't know what kind of job you're going to have. Maybe your boss just thinks you're smart and you're just out of college. And you can figure this out. Well, you can go look up what the formulas, but you'll have to be the one who sticks the things in the right spots. I'll pause for a second. Okay, so I'm going to do, this is the third term, so I'm going to say a sub n is, in case you haven't figured this out, that is a number. A sub n is the third term, so it is 4 is, and then if it's the third term, I put a 3 here, and I don't know the a or the r, so I leave it like that. So I have 4 equals a times r to the second. Does that make sense to you? Okay, that's an equation. Now let's do that same thing for this. And 100 equals a to the r, and then it's n minus 1, but this is the fifth term, so then it's 5 minus 1, so it's to the fourth. Now, I was surprised how many people really didn't know how to solve. If I give you these two equations, I'll bring this down a line just to make it on par with each other. If I give you two equations, you have to be able to solve that. Do you know how to solve that? I'll give you a hint. You solve for something. Like you figure out what's A. Once you know what A is, you can plug it in the other equation. I also found a kid last hour had a really good alternate way to do it. But I'm going to show you the normal way first. Okay, so we're going to divide by r squared on both sides. Why did I do that? So I could know what A is. A equals 4 over r squared. Now over here in the A area, I can put 4 over r squared times r to the fourth equals 100. And you could cancel some of those r's, and then you could clear the fractions, and you could solve that thing. Does that make sense to you? Now, one more thing. Did any of you think about the fact that since it's r squared, then there could be a negative and a positive answer? Very good. So, in other words, you could be multiplying by a negative number here and you would have never even noticed because you did it twice. You know what I mean? So there could have been a negative r or there could be a positive r. All right. Now, here's the alternate way to solve it that I kind of thought was cool from last hour. Here, I'm going to rewrite the two equations this time in red. 4 equals a times r squared, and here's 100 equals a times r to the fourth. And the way this kid thought was, what's the difference between these two? Well, the difference between these two is that this one's got 2 extra r's that this one doesn't have. So she thought, well, what if I made this times by r squared on this side so that it would be actually identical on that side of the equation? But then you can't just go around multiplying by r squared on one side of the equation, but you can if you do it to both sides. So then I'd like you to think that through. Do you get that this and this are now equal? So therefore, this has to be equal to that. Isn't that interesting? So 4r squared would have to be 100. That's interesting enough to me that I'm actually writing it down. I'm going to pause for a second. Okay, so let's get to your homework for typical problems. If they asked you to write something in sigma notation, do you get by now, you just make the sigma, you start with a 1. And if you want a certain number of terms, let's say you want 20 terms, you put a 20 here, and then you put the any term right there. Get what I'm saying? And this any term, if it's adding, you should have it off the sheet. A plus n minus 1 times d. Or if it's the kind where you multiply, you have a different any term, and it's a times r to the n minus 1. One of these two will work when you're making a sigma. That's the hard part. These are easy. How many terms do you have? And always put a 1 there. Okay? Questions? Yes?
First of all, do you have to write n equals 1 on the bottom?
No, you don't.
And then also, there's some problems.
You can,
that
by
have
the
a
way, put an n
zero
equals if you want. Just hold on a second. I want to address your first question because it's valid. You can put n equals 1 there, but you don't have to say n equals 1 there. And then what else?
There were some problems, I think, in the homework from this weekend that had a 0 there.
Again, when you get to pick, you want to put a 1 there. But they can start with anything they want. If they want to start with a 3 down there, they can. Or if they want to start with a 0 down there, they can. But if I'm making one, I'd always put a 1 there. Okay, moving on to this kind. This is a word problem. In the end, do you get that it has to do with a sequence or a series? What's the difference? Sequence is just a list of numbers, and you got to know how to make the next term. A series is adding up all the numbers, and we're going to give you the equations for this unit, so you don't have to memorize them. We started with that on the first slide we looked at has all those equations, but will you be able to use the right one? So let's just talk through this question for a minute. So this guy makes chess, and the king is like, dang, this is a really good game. And then the king says, what would you like as a reward? And he says, just give me 1 grain of wheat on the first square of the board, and 2 on the second, 4 on the third. I've heard different variations of this. But do you get the idea? You get a 1 here, a 2, a 4, an 8. Do you get that's basically a sequence? And in the end, the guy asks for just all of that grain is all I want. It's just, is so far up to here, the king's like, this is a paltry amount of grain. Of course I'll give you that. But then what's the punchline, of course, at the end? When you add that all up, when it's a sum of like this, it adds up to a ridiculous amount. In fact, it's more grain than there is in the entire kingdom. Like it would be, you have to give us all the food in the entire kingdom, because it seems like it's not going to be that much. But if you just keep going, 16, 32, you still might think, oh, it's tiny. If it's grain, I mean, who cares? But at the end, we're talking trillions and quadrillions because people, generally human beings, are not awesome at understanding exponential growth. Because we get like add sum. We get the whole idea of add sum each time, but we really don't get like that this isn't going like this and it's just going to be astronomical at the end. Like you could never afford to give that much because there isn't maybe that much grain on Earth. All right, so I actually, now that you understand the problem, you should be able to make a summation for it. If there's, in case you don't know this, a chessboard is an 8x8 board. Okay, so it's not an to infinity problem. It's just that the amount of grain will be so much you might, in your head, say it's about almost infinite. So how do you make a summation for this? Nick Pats. Start with this. What do I put here? Okay. Haven't been watching the videos, maybe. Ashana. Can you guys put the name tags where they're supposed to be? Go ahead. What do you start with? 1, and then you go to? 64. And then you put the any term here. Is this the kind where we need an R or the kind where we need a D? R. So are you doing A times R to the n minus 1? You should be. And then all we have to do is plug in the right numbers there. Nico, what's A?
A is 1.
A is 1. What's R?
2.
And do I have to do anything else? Do I put a number in for n? No, I don't.
No. I mean, unless you're solving.
That is your summation. It's in sigma form. There's 2 ways we could ask you that. That's it. Now, how about the actual answer to it? Well, then you'd need that new formula. Who's got a really good memory for that kind of thing? It had 2 parentheses like this. 1 minus.
R to the n over 1 minus r.
1 minus. Just that?
No, times all that times A.
Oh, there's got to be an A in there somewhere, doesn't it?
Yeah, I said all of that times A.
Yeah, I'm just clarifying for other people. Okay, so do you think that's it? Take a second, look back at your notes and see if that's the right formula.
That's magic.
Is it?
Yeah.
It's exactly like that.
Except the S and N.
Oh, okay.
Yeah.
So we don't really have to write that part, but I'm encouraging you to do that. One of the biggest mistakes I see with kids using formulas is they only write the right side of the formula and they don't have the left side. Then when we tell them, well, it adds up to 10,000, well, they don't know where to put the 10,000. Well, it goes on this side of the formula. All right, in this case, what's our A? It's 1. What's our R? It's 2. What's our N if there's 64 squares?
60.
And there's your answer. And the challenge is right there. People just don't get the 2 to the 64th is like insanely huge. And therefore this answer is insanely huge.
It's impossible.
It would probably be impossible for a, well, I shouldn't say
Oh
that.
my god.
That's classic. I could do this easy.
Can you read the decimals to me?
1.844674407 times 10 to the 19th.
Times 10 to the 19th. So we have to move that decimal over 19 spots, and we're not even super accurate because we've only got the first few. You know what I mean? So, yeah, insanely big. Okay, so let's show you what you do for homework for tonight. Here's what I would do. Do you think that there might be a word problem on the test?
Yes.
Yeah, of course. So let's do a word problem. I think I like this one better than the other one, so we're going to do number 10. Do you think there will be summations? Yes. For sure. Okay. When it says write it in expanded form, they're saying there's only 7 terms here. Can you write out the 7 terms? I think we haven't done many of those, so we ought to do that. So let's do that one. And this is a good one, number 12. And that's it. That's a small number of questions. But if you do those, you'll do dramatically better than the kids who skip it. That's all I have for you for today.